All attendees are in listen-only mode.
Hello and welcome to the Environmental Test and Design webinar. Where are the holes? Ingress Protection Testing. MIL Standard 810G. My name is Belinda Stashukevich and I am the editor of Environmental Test and Design. Environmental Test and Design, which launched in 2009, specializes in the interrelationship between electronic systems and devices and their environments. This webinar is presented by Steve Ferguson, Executive Vice President of Washington Laboratories. Steve Ferguson has worked in the compliance test arena for over 35 years at test labs and manufacturing companies designing products, developing procedures, and performing tests. He presents various courses on EMI and EMC compliance. He is an INARTE certified EMC engineer and administers the INARTE approved Washington Laboratories Testing Center. This webinar is sponsored by HasTest Solutions. HasTest Solutions, Inc. is the fastest growing provider of high-quality solutions in the field of reliability testing, customizing units from a benchtop size to drive-in models. For the full range of environmental testing chambers, to name a few: HAST, sand and dust testing, temp and humidity, salt fog, solar radiation, high-temperature ovens, temperature cycling, rain, thermal shock, walk-in chambers, triple zone chambers, and more. Visit our website for more information, www.hastest.com. Don't just test it, HasTest it. This webinar will be interactive. You'll be able to ask questions and answer polls, and we encourage you to participate. Take a look at the GoToWebinar navigation pane. If at any time you have a question, we ask you to fill out the type box and hit send. To make the screen minimize and maximize, click the arrow button. To raise your hand to ask a question or report an issue, click the hand icon. And to maximize the screen, click the middle button. We will present the topic for 45 minutes, followed by a 15-minute question and answer session. Before we begin, we have a poll question for our audience. Attendees, please answer the following question. What is your primary job? Product design, product evaluation, product testing, or other? We'll give you a few seconds to answer the question. We have a few more seconds. The majority are actually involved in product testing. Thank you for answering. Now Steve will begin the presentation.
Well, good afternoon to all, or good morning if you're in that part of the world. I thank ETD for inviting me to speak on this subject, and I look forward to hearing your questions. This is the second in a series where we did a little introduction a few months ago, and this is a topic that we sometimes omit, is ingress. And what is it? Well, for our purposes, we need to define something, and it's an entry of matter that affects the operation of the device, some sort of matter, and I'm not going to restrict it to a fluid or a dust or a whatever. Various things can enter the device, and if we're trying to prevent it, we have an ingress issue. The effects that produces catastrophic failures at times, quite frankly, it can also produce a premature failure, frequent service, and often shortens a product life because it contributes to overheating, corrosion, moisture content, and various things that cause issues with the product. There's a few MIL Standard 810G methods that I've identified, and I don't know that I have everything. Contamination by fluids, rain, humidity. I left off the original discussion point, but I decided to include it because that's basically the end result of the problem. Salt fog, sand and dust, and immersion. Now this is 810. We'll touch some other standards later on. Contamination by fluids. The test is to determine a tolerance for exposure to some liquid contaminants. It's applicable to equipment that has a high probability of exposure, but it's not for the performance evaluation of items that have to handle these liquids or contaminants, whatever they are. That's a performance thing and the ability to function. This is equipment that accidentally gets exposed. It wasn't designed for that purpose, but it may be designed to prevent issues. Let us put a word of caution in. When you're doing some testing with these products, you can get to use materials that have an environmental or health impact, things that you breathe in, you get spills, acids, things of these natures that cause skin irritation, to say the least. So you need to consider special handling and the disposal part of the requirements as part of the test. Once you're done, you've got to get rid of this. You've got to control runoff and spillage and things of this nature. So when you start preparing to do the job, include this aspect as part of your pricing scheme of the amount of time you have to deal with a project. It's caught us more than one time that we had a special handling thing that we had to take care of later. So be aware of it. The sequence, it's basically not done prior to other climatic events, things that could be affected by the contaminants or the removal. They prefer to put a new unit in place if you have something available for this test. So the idea is if you've got a salt accumulation on this, the contaminants or the fluids may not have the effects it would otherwise. Interruption of the test, you need to inspect it and resume at the point where an interruption happened. Normally the interruption is either an over-test or an under-test mode, and basically it's handled both the same way. Examine, see if there's things that you might need to replace or restart. Effects you can often see by contamination are physical, where you end up with cracking, binding, fractures of components, gasket failures, packaging failures, the box falls apart. Delamination, and this is really prone to displays that have a laminated or a conductive surface. Paint marking issues, you can't tell what button does what anymore, you lose its label. Labels of the product, operational parameters, things like that disappear. The chemical, you end up with melting, corrosion, chemical agent failure protection. Something is a problem here. And we go beyond the typical electronic equipment that we like to talk about, but it involves other things too, from materials to hardware, tires, things of this nature. All these components fail from a chemical attack not working well with the other materials that it has to deal with. The electrical or component failures are prevalent. Sometimes static electricity can be developed because of the removal of the ions on the atoms. Conduction deterioration. This is especially prone to EMC gaskets and fingers and things like that, where the fluid creeps in and causes an insulating layer so you don't make the connection you should. Or it produces insulation and isolation reduction, where circuit board traces no longer have the separation they need, and arcing tends to happen between circuits. So you watch for these kind of events, and that's part of the inspection. A lot of folks think that contamination by fluids is an external event, that they look at the surface layer and say, well, okay, all the connectors stood up to it. But what's going on in that hermetically sealed connector? Did it stay long enough there to creep in through the connector? Did it have an effect inside, and it's taking some time to examine? So opening the cover and say, I didn't see anything pour out, doesn't necessarily mean that I'm not getting swelling or it's being absorbed by the materials and we don't get the good visual indicator. So detailed inspection is a necessity. You have to pay attention to the output of this thing at the end of the day. How do we do this? Well, there's a couple of procedures they talk about. They define large systems and small systems. I have specific fluids identified. With temperature control, especially temperatures including thermal shock associated with exposure. Let's give a little bit of thought to that. Temperature control, a fluid on a vehicle where the vehicle's out in the hot sunlight, it's absorbing heat, and we get some fluid spilling on it. For instance, a cleaning solution at an airport spills on the vehicle. Does it tolerate it with a high heat? The duration normally calls for an 8-hour exposure to the fluid and 16-hour temperature soak. So we're soaking at some temperature associated with the device. It's either hot, cold, or whatever is appropriate. And it could be multiples. The guidance is provided for anticipated frequency of exposure. There's some additional information in the standard. But really we need to come back to the life cycle control plan. What is this thing going to see in its lifetime? For small systems that are typically more handled or mounted into various locations of specific fluids, and they list 26 of them, where the temperature is normally done in an ambient condition with an 8-hour exposure duration. Immersion may be the appropriate way to apply this. In general, the procedure is to use the application method of spraying, a wiping, or an immersion technique, and the exposure direction. If certain sides are kept away from the exposure to the fluid, they may not need to have the direct application. Also, whatever drainage is provided needs to be provided for this, so you need to be able to get rid of the excess. Multiple fluids, you have to consider assessment of the individual effects and the sequence for putting these things in the order of exposure. If I'm having an issue with one particular fluid prior to a separate one, and they both can be applied to this, can one prevent the other from causing the damage or ingressing? Also, some of these fluids combined, you can get some outgassing and things like that for an additional health risk. You need to provide for cleaning between exposure, a thorough cleaning. And that doesn't mean we simply just wipe it down. We've got to get this stuff out of the cracks and crevices because the next fluid is going to try to go there also. So be aware that this fluid contamination doesn't go away too easily. Working separate issues, so a good test procedure is a necessity here. Also, I need everyone to consider this test plan that don't call for fluids beyond belief. Let's say if you had small systems and somebody comes in with a requirement, well, which fluids? And they say, well, whatever is applicable. Well, whatever is applicable, because 26 fluids means there's 26 days of work going on, plus the cleaning and handling, etc., plus all the fluids and the use of the fluids. So you end up with an exhaustive set of tests that people don't want to pay for, and realize suddenly that they need to deal with all these situations. So we need to consider what's realistic here. The life cycle plan needs to be there. Acceptance of the result is through inspections and functional testing as required. And again, as I mentioned earlier, let's be comfortable that it's a thorough inspection is done. The rain test comes into being as one of the next ones listed. It's used to determine the effectiveness of seals, covers, drains, and any water removal systems, physical deterioration associated with it, and protection by packaging. A lot of things say if a packaged item is provided, then the rain test may be exempt and the package only gets the evaluation if we're only exposed during the transports or things like that where it retains in the packaging. Applicability, if its equipment's likely to be exposed, including if the packaging is likely to be exposed. That could mean sitting on the dock waiting for shipment or whatever. So not only are we testing a product, we may be testing the packaging material as the product, not necessarily the product with packaging. The sequence, normally it's done after dynamic tests, meaning those things that like shock and vibration and those kind of events that would cause the movement of materials and allow holes to open up. Consider the effects of thermal tests and effects on gasket variance from heating. Sometimes a gasket overheated could cause a permanent set and not seal properly after it's cooled. So be aware of the expansion of metals that could have some ill effects there. Interruption is resume at the point of interruption. Almost always that's the case. If you do an overtest for some reason, obviously, and it passes, that's not a problem. If you failed and you've poured way too much water into it, you may have to consider restarting it from scratch to find out what really happens there. The effects from atmospheric rain, radio and radar signaling that's affected, optical issues, electrical issues because we end up with moisture and it erodes and causes arc overs and the like. The impact from physical damage, and the impact part of the effects produce physical damage from the droplet speed. It's like taking a beating in a storm. The impact does take some damage into there. When I'm looking at hard surfaces like metals and the like, you don't really see that by itself as being the effect, but the deterioration of paints and etc. causing the readability of labels, that's a problem. And if it does ingress, material swelling, the electrical portion of this, and the associated corrosion, because the moisture that it does ingress results in a steam bath going on inside from the heating of the material during operations, so you end up with corrosive effects associated with it. Procedure 1 is called out for rain and blowing rain. It's an outdoor unprotected material for devices. It says these 1.7 millimeters per minute or a 4-inch per hour rain rate at a 40-mile-an-hour wind speed, 18 meters per second. And you expose any surface to this wind-blown rain, this blowing thing. It's an exaggerated test can be used as an alternate for procedure 1 for large items where you use a pressurized spray like a cleaner, a spray cleaner. The droplets traveling at the same speed associated with a 40 pound per square inch pressure, and that in order to get the rate and droplet size, you'll need a certain head size or the sprayer's head. Again, you apply it to any exposed surface that would be exposed to the blowing rain or this pressure. Procedure 3, the drip test, or dripping water from a pan with a specified hole pattern. It produces a volume water of 280 liters per meter square per hour. You need to restrict the distance when you're doing these blowing rains, especially to prevent droplet size reduction below the target diameter. If you have a long distance, they tend to expand out and become smaller drops, so you need to get that droplet size taken care of. Rain also calls for preheating of the test article for many occasions. If an item is preheated, it's out for solar exposure or just a hot item, you need to get it up to operating temperature or exposed temperatures, those that can acquire from the environment. And that preheating will allow for the ingress because materials will now start cooling and you'll see the metals contract differently. Assess the compliance. You need to establish criteria because ingress could be allowed if it can tolerate it. So how much is too much? So a pass-fail criteria clearly needs to be determined for this test. Humidity testing, resistance to warm, humid atmospheres. And my question is this really an ingress method? In my opinion, I consider it to be that because we're concerned about what happens inside a device, what's going on internally from this moisture being exposed all the time. Now, there's a lot of things that happen outside, but ingress is also applicable, in my opinion. Applicable equipment deployed to the simulated environment, and these environments can be various things. Nothing anymore in the military world stays in one place. You go from hot, dry to hot, wet to cold, to you name it, and the same equipment needs to be virtually able to go anywhere. If it has a fixed one-place deployment for large systems and etc., then you have to tailor it accordingly. But in general, products, especially small pieces, have the worldwide exposure. The sequence calls for not before tests that could be affected by irreversible effects of the humidity. So therefore, if I have the humidity causing an issue, a corrosive effect that I can't determine if salt caused it later or some other test caused it, I need to be able to separate the two. So you have to watch for these kind of tests that you don't mislead yourself into the effects when you get your inspection. Never after salt fog, sand and dust, or fungus testing. Those have effects on humidity and the ability to creep into systems. Dynamic testing could aid in identifying humidity issues prior to humidity. So sometimes doing dynamic testing prior to this could help you identify the issues. So in the sequence, you might put dynamic testing ahead of humidity. Interruptions, if you got an under test, you need to restart at the last completed cycle. And what is a cycle? A cycle is typically a 24-hour exposure period. An over test, you need to inspect, replace, and restart if needed, or restart at the last completed cycle. The effects are surface affects the corrosion, the coatings, the friction, you remove coatings, and etc. The material, insulation, reduction, delamination, removal of lubricants. You end up with oils and films that prevent friction issues, so you end up with the lubricant missing. Optical things where the moisture creeps onto the lenses, and etc., so you cannot get the visual things. And swelling of components. For any of those that are familiar with a EMC test facility shield enclosure, high humidity eventually creeps into the pressed wood holding metal plates together, and that delamination or swelling of that material causes those panels to open up, and you lose the whole shielding effectiveness of your room. It's just an example, but many things have the same kind of problem. The condensation from humidity gets to the electrical world, and the fogging also adds to the thermal effects where it tends to retain the heat. The humidity has a couple of procedures, the storage, transient, or natural humidity cycles, which calls for a conditioning period for 24 hours. Get it to a stable state before starting the cyclic testing with 24 hours per cycle. The storage with operation test, if you've elected to do that, the operation is done every 5th cycle. So it goes into storage mode, and then an operational test is done every 5th day. The duration is 15 to 180 cycles. Everybody says, what? I didn't read that. Well, that's what the standard says, and the life cycle program calls for that. Any of these tests are up to the minimum time we see is 15 days, but yet all of us are seeing 10-day or 3-day humidity exposure periods called out all the time for these durations. The procedure 2 is an aggravated cycle, which calls for the conditioning like that. Cyclic testing again with 24 hours per cycle, and checks at the 5th and 10th cycle with a 10-cycle minimum. Basically, we've increased the exposure rate, the depth of the humidity or the temperature. This could produce for a constant humidity or temperature humidity. That is quite frankly called out more frequently on a tailoring process than most others. So when the time gets shortened, they take care of that. That chart you see over there is just one of the cycles. That's one of the cyclic aggravated, I believe. No, that's a cyclic natural high humidity. A poll question.
I'd like to interrupt you for a second, Steve, to ask a poll question to our viewers. Attendees, please answer the following question. If the environment is defined as high humidity, what test approach would be used? Steady state temperature and humidity, constant temperature with minor humidity variance, constant humidity with minor temperature variance, or cyclic temperature and humidity. We'll give you a few seconds to answer the question. A few more seconds. We're actually seeing a bit of a tie between A and C, so Steve can let you know what the correct answer is.
A and C, 1 and 3, I hope.
Yep.
Okay. Actually, you can make an argument for any of them. Okay. Any of the things are used, and quite frankly are. Item 4 is what the standard calls out for some cyclic temperature with humidity. It's almost always called out. The number 2, the constant temperature with a humidity, minor humidity variance, is also one of the choices to make. But I'll guarantee you, because of the way you guys answered it and the fact that we've all seen these various events, you could make a case for almost anything here becoming the right answer here. It's an aggravated test. High humidity typically calls for cyclic temperature with humidity. But don't fail to consider other ones available. There are several choices, including the ever popular tailoring the exam. Let's continue with salt fog. It's one of the pieces that we have. Test determine effectiveness of protective coatings and finishes. Is this an ingress method? Well, the answer is obviously it is, because protective coatings apply to internal pieces as well as external. So we have to consider that does salt gets into this thing and bring corrosion through this. Applicable to items with a significant exposure to high levels of salt in the atmosphere. This happens at beachside areas, marine deployment things on ships, etc. We're not looking for things under the water because that's a high exposure, not atmosphere, but that's salt water. It's a different beast entirely. The sequence is after other climatic events, meaning salt can interfere with other tests, so you do this pretty late into the sequence. Avoid using the same test sample for salt fog and fungus and humidity, but if required, do the salt fog last. You have to pay attention to the cleaning for these other things. Fungus and humidity, make sure that you've got this thing inspected well before you go do the salt fog, because the ill effects of humidity have to be given time to manifest themselves before you go in and apply the salt and cause the problems. No one has any time to wait, so pay attention to the inspection very thoroughly. If it's required, sand and dust after the salt fog. So you can beat the thing up after you've got the corrosion well established, apparently. The interruptions, you generally have to consider a restart at the interruption point. The inspection to assess the impact. The interruption point is everything that's completed to that point generally is considered to be done. The effects, obviously, the corrosion is the most obvious effect we see, the structural deterioration, acidic formation, things of this nature on the material as well as creeping into the material. The electrical, the corrosion of the conductors, the tracking changes on circuit boards and layouts, and salt getting into various articles and causing the arcing point between contacts, because it will accumulate and it will also hold moisture within it, so the electrical tends to get deteriorated. So if exposed, this takes a lot of cleanup to bring the unit back to a post-repair state. The physical effects associated with it, the clogging, the binding, the blistering effects of the salt. And watch for connectors, things that we see externally getting into the connectors. Well, it was there. It's obvious it's going to get into there. And you didn't have a connector cover or a mating connector on it to protect it. Does this allow the salt to creep through the metalwork and cause corrosion crept inside the test article? We've seen this occur at random where a hermetically sealed connector, the salting environment tends to bind through. So it's one of the inspection criteria is a thorough inspection inside. Procedure typically calls for conditioning the chamber for 24 hours prior to exposure. If you've not ran your chamber in a while, you've got to get it up to speed. The fogging or the mist of a 5% salt water by weight solution. So 5% salt by weight to the equivalent water in weight. A 48-hour exposure with the 48-hour drying, alternating 24-hour events is normal. We do see occasions where extremes are called out. 28-day salt and 156-day salt environments are called out by very particular standards. The post-test inspection and functional things need to be considered as part of the procedure. Handling it, you need to keep away from it. Oils from your hands and all of the various contaminants from the handling will affect the results of this test, where you don't get the corrosive effects or understand where it's at. And these become visible to you during the event. So the handling is pretty touchy. When you realize, well, I got to put this thing in and out of a container. I've got to take it out for the drying cycle, put it back in, etc. So it has to be handled. Use some plastic gloves. Keep the body oils away from this thing. Avoid getting the gloves contaminated. Put on some clean ones. Handle it as minimally as you can to avoid the issues associated with that. You have to consider the fallout rate. It says the procedure to verify a rate of 1 to 3 milliliters per hour. And by the way, Mill Standard 810G calls for an 80 cubic centimeter fallout rate. It should be 80 square centimeter. It's an area, not a volume. 810F had it correct. We changed to a cube function in G in error. So it's a volume, not a volume measurement, it's an area measurement, so it's a square. Sand and dust comes into the being as one of the ingress tests, obviously. The test determines resistance to dust. And these are called particles that are less than 150 micrometer diameter, and sand particles between 150 and 850 micrometer diameter. So that's just a clean definition of what's sand and what's dust. Applicable items exposed to atmospheres laden with sand and dust. Caution, health hazards could be associated with exposure. Use protective personal equipment or personal protection equipment. Keep the dust mask in place. You need to be in here because part of the process is to rotate the unit at various times, so watch for health hazards. Silica is used as one of the dust items, and it causes scoliosis, I believe. So it's a health thing. Pay attention to doing sand and dust testing. In addition, if you happen to get in there with exposed skin in the sand, you get some abrasive actions going on. The sequence, a lot of judgment is called for here. You may need the thermal test data to support the testing. Well, quite often you do. A unit is supposed to be exposed to the high temperature for operating or storage during one of the tests. If you don't know what the high storage or high operating temperature is, then how do you know how to do this test? You don't. So the idea is, well, it's spec to operate at 55 degrees C. Well, you may see that the test only passed at 50 and they get a spec change. So you need to get the test data to know what is going to happen. You don't want to have a failure here because of a thermal issue that you wasn't aware of. Residue from the sand and dust can influence the humidity and corrosive effects. So usually this is done pretty well towards the end if you have to use a single test article. Again, this is one where a new test article or something that hadn't had these effects, climatic effects, could be the supporting piece. Vibration beforehand shouldn't be a problem. Temperature, probably not a problem. Humidity beforehand, possibly a problem. So you need to consider the sequence and deal with that in your planning. The interruption, if you have an under test, you resume from the point where the under test started. If you do an over test, you've got to inspect it. Remove the accumulation that's in excess and resume. You may have to adjust the test duration. If you're very close to finishing, you may not want to run it through the whole time again. The effects, the abrasion, the wear, the chafing, things like that. The penetration results in clogging, ventilation and airflow restrictions, and filters. If you've got a filter that's supposed to take care of this ingress for the ventilation system and the filter clogs, so you've got to service it every 4 hours during these events, is that filter what you can live with in your environment? Or do you have to consider some other means of preventing this penetration? The physical things has interference, optic restrictions. Obviously during these events you do get the physical aspects. So it may not make sense to do like an optic lens as an operational test, because obviously it wouldn't be seeing anything but the blowing sand or blowing dust. And so you wouldn't really know good performance, but then after the test, did you get wear on it? Did it cause it not to function anymore? The blowing dust is procedure 1, the temperature at ambient with high operating or storage temperature, and at a high operating temperature with a humidity below 30%. This prevents you from clogging up the dust particles. The air velocity is stated, it's pretty wide along with the concentration. You've got a lot of variables in dealing with that situation. The orientation says the most vulnerable face and rotation if needed, dividing the duration among the faces. So if you've got 6 faces that could be exposed here, you divide the total 6-hour temperature, the dust exposure, for an hour for each one of the faces. And 6 hours again at the high storage or operating temperature. Again, at both these items, the duration is split among the faces. And the rotation applies to that, even that whether you're doing storage temperature or ambient. Would you need to do a storage temperature and an operating temperature? I don't know. Sometimes the specs may call for this exposure differently. Normally, if you're exposing, you have to operate. That's the preferred method to examine this because the operation tends to bring things to a maturity, shall we say, of the years. The operation of test plan should address any operational restrictions or any service requirements. If it's normal in the thing to service it at a frequent interval during events of high dust, then you might need to provide service during the testing. Procedure 2 is a blowing sand. Again, this is done at high operating temperature storage, not an ambient test, with the air velocity of 18 to 29 meters per second. Let's see, 18 meters per second is 40 miles an hour, so you can guess from there. The concentration for natural condition using a 0.18 grams per cubic meter. But when you have exposure in proximity to aircraft, helicopters, or other things where this concentration can be severely increased, you would have to increase the exposure to that rating. The duration is 90 minutes for each vulnerable face. So if you've got 2 faces, it's a 3-hour kind of evaluation. So it's 90 minutes per vulnerable face. So a 6-hour test, I mean a 6-sided thing would be proportionately larger than the normal 6 hours. Immersion testing, it's to assess withstand immersion or partial immersion applicable to items subject to this situation. It may require operation during test, depending on the item, and may substitute for rain if configuration is the same. Sometimes an article will be submitted to immersion when it's in a transient pack, but not during its operation, so it wouldn't be the same configuration. But if an operable unit, say a body-worn or belt-worn, is subject to the immersion because they go into the streams or fording, then the idea is it could be operational or not, depending on the product. If it's the same configuration, this can be substituted for rain, and your plan needs to provide for that. The sequence, there's a lot of different philosophies on this. Conserve the test article. Do immersion prior to most other climatic events. That way your test article is in good shape, so you're not showing this thing. It's likely it'll pass. It's not subject to causing other damages if it passes. So they conserve the test article to see that no damage gets in there. There's also a philosophy of maximizing disclosure of issues. You do the immersion before and after the structural tests. So now I'm trying to find out, did structural tests affect it? My personal view, I do the after the structural and climatic, because I've seen events way too frequently where the immersion test shows its ugly head after a climatic, meaning temperature setting gaskets or expansions of metals, differently than before. Also the structural, if it's going to crack and fracture, we need to find it out. So the idea is to find the problem. Don't conserve the test article, find the problems, because the problems are going to be realistic. If I fielded 100,000 pieces of something and it's defective, the time to find it is before I put 100,000 of them on the street, causing all kinds of issues. The under test, you treat it like it's a non-test, okay, and repeat the thing. And over test, accept it if it's compliant. Test with a new test sample if it's a failure. Well, we need to ask ourselves a question. What is an over test? Well, I'm supposed to immerse it to 1 meter. If I immerse it to 3 meters, is that an over test? Yeah, could be. High pressure or things of this nature. The effects from electrical shorts, lubrication failures, especially any external lubricants, get washed off. So you might need a water-resistant lubricant if this is going to be a real situation. Engine operation failures, corrosion effects, and obviously contamination of any burning or materials that's associated with ordnance where it has to ignite or things like that, and immersion causes it to deteriorate where it doesn't function properly. The procedure calls for conditioning and opening the doors and covers operated during normal use 3 times. Elevate the sample temperature either 27 degrees C, 10 degrees, or nothing, depending on how it's used. Immerse into a depth of 1 meter or greater depth. You'd need to use a pressure vessel to expand the pressure on this, or you could go to a deeper place if you have it available. The duration is the anticipated use, but not or 30 minutes. During the test, look for air bubbles that can indicate leaks. Also, potentially weighing the unit before and after could be an indicator that something happened internally. Do the inspection and the test. Again, like we said on one of the other items, be conscious of the pass-fail criteria. How much is allowed to come into it? Okay. If it goes under for 30 minutes and there's a minimal incursion, if that's an acceptable condition, this needs to be decided before the failure occurs, and we're negotiating to see if it's going to be acceptable. So come up with an idea of what is the pass-fail. Procedure 2 calls for forwarding with conditioning, much like the previous, with where you drive or tow the sample through the required depth. The depth, the detailed guidance is provided, so you have to look at the forwarding guidance versus generic. The duration is the same as procedure 1 for 30 minutes or the expected duration. And the inspection and test is the pass-fail criteria. Tailoring. Development of an evaluation program based on common sense considerations for the material application. The standard request tailoring be used. The details of the evaluation and the test method details needs to be a party to this. Any conditions, extreme conditions, special conditions can be considered. So consider all these things instead of taking the guidance straight out of the standard. The test sequence need to be made part of this tailoring. The defined for selected methods, it's clearly there, and then using judgment if it's not defined. Documenting your sequence gets everybody on the same page. The problem is maybe how to get your tailoring accepted. You're not following the standard. You've modified it. So now reviewers that are less than experienced may say, well, wait a minute, is this really a good evaluation, and not really understand your goals. So you have to have a good rationale for why you're deviating from something that may be clearly defined. Okay, why am I doing a 3-day humidity versus a required 15? Well, I want to save some money. That may or may not be an acceptable answer. Poll question for you, Belinda.
Okay, I'd like to ask the attendees another question. Attendees, please answer the following question. How do we determine the test duration? Please select one. Mill Standard 810 specifies the duration for each test. Test procedure defines duration. Life cycle analysis or deployment locations. We'll give you about 20 seconds to answer this question. Answers are still coming in. Okay, the majority, slight majority, went with question answer 1. Back to you, Steve.
Well, 810G doesn't tell us very much about it. They sometimes will suggest a minimum, but the life cycle analysis is supposed to be done on all these developmental programs. What is my exposure? What's my life cycle? What do I need to do this? You need to use that thing as part of the deployment locations will fit right into that life cycle analysis. Your test procedure is based on the life cycle analysis. So the life cycle analysis acts like the key for everything, with 810G being the last resort. So you need to consider the tailoring, but life cycle things are clearly the key answer in doing this. Again, it's almost like everything feeds into off each other here. So any one answer by itself could be a good answer. But again, the program calls for development. So let's look at that as being our primary. We'd like to have that life cycle analysis. Now, most of you answered 810G, as Belinda indicated, because that's where you're left with. You don't get these other things. Nobody writes the procedures. They don't want to spend the money. They'd rather fumble and mess around in the lab so nobody knows what they're supposed to be doing, and just follow 810, and it's inadequately in defining what you're trying to do here, especially on sequences, durations, and any extremes. So we need to get a good procedure going on based on the life cycle analysis. The test procedure is basically derived from the life cycle environmental profile. That's the life cycle analysis. Why does it seem to be such an elusive document? Well, the efforts are used to buy commercial off-the-shelf equipment, COTS. So nobody wants to spend any money except, oh, go buy the XYZ from Radio Shack or from Mini Circuits and expect it to pass all the mill requirements. The products are deployed everywhere, so the worst case is often stated. With anything going anywhere, it's there. Now, this all is well and good until the totals start appearing. The testing goes on forever, and the dollars keep growing. You ended up with a 9-month test program that cost an arm and a leg for something that did not get any definition. This test procedure represents an agreement that needs to be made and documented. It details the tests, the durations, the sequences, the levels, configurations, all the details, any special considerations, like which fluids are appropriate here. The user and the manufacturer now have a scope defined of what they're going to do and what the expectations are on both parts. The test lab knows its obligations too. It follows this procedure. Don't forget, the procedure should have the escape clauses, a way out. If you have an event that says, okay, it looks like corrosion, but I'm not sure. If I wipe it, does it go away? What's allowed here? Also, if you get a random event, it comes out of the vibration table and you do a post-test functional, and it didn't operate, and you go over and then suddenly it does start operating. Well, is that a failure or not a failure? How am I going to treat that? Do I have to shake it again? Do I ignore it? Well, it recovered on its own. I didn't have to repair anything. Can I repair an article? Is that one of the allowances in doing something? So these procedures need to define how you get out of the situation. Do I rerun that particular test 3 times, or just run it once more, or replace the article and do it again? Have the way out. Define how deviations are processed and accepted. Who signs them off? What do we do in the meantime? If we're going to change our procedure because, well, we thought it would fit here when we wrote the procedure and it won't quite fit through the door, so we got to do this other thing, and we got to use a spray instead of an immersion. Is that going to be accepted? Well, somebody's got to be able to sign off on it without it taking 3 months of review. You need to keep the test program going. In that test program, get your acceptance criteria. Pass-fail criteria must be clearly defined, measurable, have some objective measure, a value that defines acceptance, a tolerance. Plus and minus 0 is not a realistic tolerance. Quantitative, if at all possible, have a numeric value, change by 3%, change by 1%. Subjective issues, and they do happen, needs identification of who's going to decide. How much ingress of water is too much? It may not be a measurable quantity. Of course, you could say, well, if you pour out more than a 1/4 ounce, that's unacceptable. So that could be measurable, but things like quality of readability of a video screen or things like this, somebody's got to decide those things, and it's not necessarily easily done in a measurement, yes, no, pass, fail. Your support and monitoring equipment should not be subject to the test and should not influence the results. If I've got a wireless network connection that has to be made to some PC to see if it's working or not, and I put this test article in a metal box to do a humidity test, is the wireless network going to communicate? Do I need to put an antenna inside the metal box from the support equipment? What do I have to do to make it work under the test conditions? And whatever the support equipment is shouldn't be the failure point. A lot of other standards come into being instead of 810, the IEC, the International Electrotechnical Commission, the 668-X, which is a whole series of standards specifying various environmental tests, DO 160, G is the current version for commercial aircraft, and there's a lot of special application standards dealing with commercial shipping, electrical power production, space exploration. They all exist with a common theme, tailoring and life cycle considerations, just like 810 calls for. So bring that into your equation. I'm open for questions. I want to thank HasTest for sponsoring here and answering questions that you may have.
Thank you, Steve.
Did we receive any?
We're getting there. We would like to have a call for final questions. Please enter any last questions you may have in the navigation pane. We have received quite a few inquiries on where to get additional information on this topic. There's a vast amount of content found on our website, www.environmentaltestanddesign.com. You can also email us at info@etdnews.com with specific needs, and we can direct you accordingly. Steve, here's a question for you. Why isn't acidic atmosphere testing not considered as part of the ingress testing?
Ooh, tough question. It could be. I didn't think about it per se because the method used is not as prone to the ingress, but it clearly could be considered such. I may have just missed it. Let's not ignore it. It's treated a lot like a rain test, but it includes the acid parts, so you get the corrosive effects. So it's very likely if you had ingress of rain and et cetera, you'll get the ingress on the acidic atmosphere, and if it would be something you'd need to face, then you'd probably almost declare that it would be a problem based on these other tests. I guess that's as good a non-answer as I can provide right now.
Okay, here's another question. You indicated a personal view regarding doing immersion after structural and climatic tests. Are there other sequence items that need this consideration?
Could you repeat? I didn't hear one of the words there, I think.
Sure. You indicated a personal view regarding doing immersion after structural and climatic tests. Are there other sequence items that need this consideration?
We all have things that we bring forward in the personal experiences. I have encountered a couple of things that tell me that vibration or a structural kind of thing done after a temperature exposure can have some influence. I remember an item where we were evaluating because they were having high failures, and they had 50 samples to go through vibration and temperature. Okay, and so this says we're going to send you 25 for vibration and 25 for temperature work. And when I saw what he had, I contacted the customer and I says, in my opinion, we need to do the 25 in temperature and then put them on the vibration table. And right away, it's a sales pitch, do more business. And I says, because I've got a concern that part of your vibration dampening material could be hardening from exposure to climatic or temperature events. We did the vibration test on new articles. 3 out of 25 failed. We did the vibration test on 25 articles that we went through temperature first. 20 of the 25 failed. So it definitely revealed a problem with his potting compounds and not working well in the environment that he had to tolerate. So these considerations come into being all the time. You have to look at these on your own to see if you're going to accept those kind of events. It's part of the tailoring process, so just randomly doing the test is not necessarily a good program. We in the test arena are often faced with being thrust upon us. Just go do these tests versus thinking about what the product is. If we get the option to go ahead and support the client very well and analyze his product, which we never get the time to do, we'd like to be able to support him with those things where we bring our experiences to maturity and be able to speak with them. That particular customer was very gracious about, saying, when I first said you're just running another set of tests for another bunch of money, and I said, well, I really had an issue with that. He said, well, it worked out nicely for me. I'm glad you suggested it. So use those kind of things. Okay?
Okay.
Anything else?
We have received so many great questions that we will try to address in the future. Steve, thank you again for your time and expertise. Webinar attendees, if you have any more questions that we didn't answer here, please send us an email at info@etdnews.com. A recording of this webinar will be available on our website, environmentaltestanddesign.com. We will also send a link to all participants shortly. Thank you for attending.